Hey guys, it's me Skylar. So I'm going to be talking about dilations. So dilation is a transformation that produces an image of the same shape as the original but is a different size. So to fully understand dilations, you got to know a little bit of vocab. So if a dilation creates a larger image, it's called an enlargement. And if a dilation creates a smaller image, it's called a reduction. So there's this thing called the scale factor. Remember that. And it's the ratio a dilation moves by. It's really important. So keep that in mind. And there's also the center of dilation, and that's the fixed point on a coordinate plane where the dilation occurs. So scale factor is so important that it gets its own page. So here it goes. So if there's a scale factor of 1 or greater than 1, it's an enlargement. If there's a scale factor between 0 and 1, like a 1/2, 1/5, that's a reduction. And if the scale factor is exactly 1, the image is congruent. So we'll start off with a simple example. This is example number 1, and it's an enlargement. Keep in mind the scale factor is 2. So the original image is the image shaded in purple, and the enlargement is the image in green. So all you need to do for this dilation is take the original coordinate points and multiply them by 2. This is example 2, and it's an example of a reduction. You know that by the scale factor of 1/2. Greater than 0, less than 1. So the original image is the image in pink, and your dilation is the image in orange. So the same thing as example 1, all you need to do is take the coordinate points from the original, multiply them by the scale factor, both x and y, and that gives you your new points of your dilation. So for both example 1 and 2, all you need to do is take the x and y and multiply them by the scale factor. Now what if you have a dilation that's not centered at the origin? The image right here is not centered at the origin. The original image is the square in purple, and your dilation will be the square in pink. So if your image is not centered at the origin, instead of using the coordinate points, you're going to measure the distances. So for this dilation, the scale factor is 1/3. So you're going to measure the distances of each side. So that's AB, BC, CD, and DA. And you're going to multiply them by the scale factor. And those will give you the side lengths of your new shape. So this is when it starts to get a little bit rough, when everything looks confusing and nothing's on the origin and there's not really any axes intersections. So if you look on day 48, number 2, you're going to find a question that gives you 2 circle equations and asks you to find the magnitude and center of dilation. The question starts out with the equation in black. X squared minus 14x plus y squared minus 4y is equal to -44. So in order to put that into a viable circle equation, the one in blue, you're going to have to complete the square. So if you don't remember, completing the square is taking the number, which is 14x and 4y, dividing that by 2, and you're going to get 7 and 2. So keep those numbers handy, but after you square those numbers, you're going to get 49 and 4, and you're going to add them to the end of the equation. To complete the process of completing the square, you input that number you originally got, the 7 and the 2, into the x and y parentheses. After that, you just put everything together and you get your circle equation. And so the circle equation will be x squared minus 7 plus y squared minus 2 is equal to 9 squared. And so that gives you your center and your radius. For the center, it's always the opposite of what's in the equation. As in the equation, the 7 and the 2 are negative. The center is 7, 2. And the radius is 9. So in order for this equation to be a dilation, you need to have 2 images. So there's 2 circle equations. You complete the same steps as you did on the last equation, completing the square, finding the circle equation, and getting the center and the radius. So after you have those 2 equations, all you need to do is plot your circles and find a common tangent. And that common tangent line is super important. In this case, the common tangent line is x equals 5. After that, you're going to find a common chord line. So a line that goes through both centers of both circles. I used point slope form, which is 4 minus 2 is equal to the slope of this line, negative 2 over 4x, parentheses 7 minus 3. So in order to find the intersection of these two lines, you can either substitute x or set both equations equal to each other, and that will give you the intersection point. And in this case, this intersection point is the center of dilation, one of your answers. So that's really important. For the next step, you're going to take the center of dilation and find the distance between that and the center of your first circle. So if you do the distance formula between the center of dilation and the first circle, that is equal to the square root of 5. Now you're going to take the whole thing, the center of dilation point, and find the distance between that and the second circle. And if you do that whole distance formula, it equals to the square root of 45. So you take those two numbers and you put them in ratio form. So the square root of 5 in relation to the square root of 45. And simplify that, and that equals 3. That 3 is your vector magnitude, or your scale factor. So that was dilations, both easy and hard. Just remember, scale factor is really important. If you have two circle equations, you got to complete the square, find the center and the radius, common tangent line, a common chord line. That intersection is the center of dilation, and find the distances and ratios of the center of dilation in relation to the center of each circle, and that equals your scale factor or vector magnitude. So that's really all you need to know about dilations. This was Dilations with Skylar Rivera.